So good afternoon, everyone. Thanks very much for joining us. Today, I'm exceptionally excited and exceptionally pleased to introduce our speaker, Bjorn Lomborg, who is president of award-winning think tank, the Copenhagen Consensus Centre, a former director of the Danish government's Environmental Assessment Institute in Copenhagen, and best-selling author, having written such works as The Skeptical Environmentalist, Cool It, Smart Solutions to Climate Change, Comparing Costs and Benefits, and the book False Alarm, which I highly recommend and which is the topic of today's event. I think a theme of Dr. Lomborg's book, False Alarm, is that inaccurate and misleading claims about the climate are sometimes uncritically accepted. For instance, news outlets such as CNN have recently proclaimed that 2030 is the deadline for saving civilization, whereas UN climate scientists predict that the expected damage climate change will cause by the end of the century is approximately 3 to 4% of GDP. So despite this climate hysteria, the science suggests that there is indeed a real problem, but it's a manageable one. And on that same theme of criticism, Popper wrote, if we are uncritical, we shall always find what we want. We shall always look for and find confirmations, and we shall look away from and not see whatever is dangerous to our pet theories. In this way, it's not only too easy to obtain what appears to be overwhelming evidence in favor of a theory which, if approached critically, would have been refuted. And with that, I give the floor to Dr. Lomborg.
Thank you very much, Sam, and welcome everyone. And this is such a weird world where we're all interacting via Zoom, but it's wonderful to virtually see you here. And I'll look forward to give you a presentation. Because Zoom is such a hard tool to work with, I proposed to Sam, and he accepted that I'll basically be doing my 45-minute talk on the book. And you know, if you have a burning question, ask it to Sam, and maybe he'll interrupt. But otherwise, save it to afterwards, and we have 45 minutes where we can go into all the detail. And it's also a little easier because I find often when I give talks that people want to sort of interrupt at the first slide, but then they realize they much rather wanted to have interrupted me on the 34th first slide. So you know, you'll probably get the benefit of waiting. So I'm just going to try and share my screen. So, well, I'd love to talk to you, and Sam has already given away the store in a sense, to talk about how do we think about climate change. And it's obviously going to be a combination of several different things. It's going to be a little bit about what we are overly alarmed about, then what is the real problem, and then how we're not fixing it right now, and then how we should go about fixing it. Because as Sam also pointed out, global warming is a real problem. It is something we should be concerned about and something we should fix, but we should actually try to fix it smartly, also recognizing that there are many other problems. Depending a little bit about how much time I have at the end, I'm also going to talk a little bit about all the other stuff I do, which is all the other global challenges. Because obviously, if global warming was our only challenge, sure, we could spend all the money we wanted on that, but we also have lots and lots of other problems on the planet. And that's one of the reasons why I think it's crucial that we get a sense of proportion of the climate challenge to all the other challenges that are also awaiting our attention and our cash. So with no further ado, let's just drop right into it. So global warming, real and man-made, this is not the conversation here. It's not a question of, is it real or is it, you know, absolutely, it is a problem, but we need to get a sense of proportion. It's often exaggerated, often vastly exaggerated. Let me just take one. There's obviously lots and lots of examples, but I think our Secretary General of the UN has given lots of really great quotes on how you can exaggerate this. So I'm just going to take Guterres. He tells us the world is facing a grave climate emergency. Every week brings new climate-related devastation, floods, droughts, heat waves, wildfires, superstorms, and and he actually tells us we're in a battle for our lives, and climate change is the biggest threat to the global economy. There are some issues, but mostly this is wrong. We're in a battle for our lives, no, and I'll show you how climate change is the biggest threat to the global economy, no. There is a problem. It's not the end of the world, if you will. And again, I would love to, but we only have 45 minutes. So I'm just going to limit to a few things. And again, please ask afterwards in the questions. I'm just going to show a few of the examples of things that people often will pull out and say, see, this is getting worse. So first one is drought. This is the typical picture that you see if you hear climate presentation, this sort of parched land and how we're no longer going to be able to survive. Well, actually, if you look at global drought, we have data back from early last century. It has been not increasing. Wow, there you are. I'm not sure why that didn't work out. Anyway, so it's been declining, not increasing the amount of area on the planet that's in severe drought. If you look at what the overview ensemble, so the US Climate Change Science Program, so their IPCC says about droughts in the US, droughts have for the most part become shorter, less frequent, and cover a smaller portion of the US over the last century. I would challenge most people who live in the US to say that that's the impression that they get from the news reporting. And that's, of course, because we always hear about a place that is in drought. We rarely hear about places that otherwise would have been or used to be in drought, but no longer are in drought. So there's an overrepresentation of things that happen and underrepresentation of things that don't happen. But of course, if we're going to make a correct assessment of the world, we need actually to take both of those into account, and we don't. And that's what the US Climate Change Science Program, their IPCC, tells us. If you look at the actual IPCC, the UN Climate Panel, they tell us that now there's a low confidence in global scale observed trend in drought. So we honestly don't really know which way it's going. And in the future, they estimate that there's medium confidence that droughts will intensify in some seasons and areas, overall low confidence elsewhere. And this is a recurring point in what I'm trying to say here. It is not such that we have seen dramatic more drought. Actually, if anything, we've probably seen slightly less. But there is a problem. And yes, in the future, it is likely that some places actually will see more drought. This is one of the reasons why global warming is a real problem. It is something that we need to fix. But again, it's very, very important not to get the sense this is an all-out devastation right now and it's just getting worse. It's not right now. And it probably will get a little worse in the future. Likewise, if we look at floods, floods obviously being one of the other things that Gutierrez mentioned and many others also emphasize simply because they also are great for TV. Again, if you look at the IPCC, they actually say there continues to be a lack of evidence, and this is the latest assessment from 2013. There continues to be a lack of evidence and thus low confidence regarding the sign of trend in the magnitude and or frequency of floods on a global scale over the instrumental record. Basically, we don't even know if it's gotten worse or better. If you look at the cost, and I'm also going to look at a lot of this, but basically the cost is the actual impact to humans. Of course, that's mitigated by the fact that as we get richer and have more infrastructure, we both have more things to be damaged, but we also have more ability to actually handle those damages. If you look, and again, I'm just showing you the US data because that's where we by far have the best long-term data. US flooding cost in percent of GDP have gone down dramatically. They've been reduced about tenfold from about 0.5% in the early part of last century to about 0.05, 0.056 around now. We only have data from 2019. That's the last that's been updated. What that tells us is that yes, flooding is a problem. It used to be a much bigger problem. It would probably impact the economy, it impact normal people's lives much more on average in the early part of last century. Most of that is because of wealth. Most of that is because we're better able to tackle these problems. But what it also tells us is that if we just look at the impact and forget the physical impact, how much water is there, and forget what are our abilities to handle it, we get a very distorted and very negatively distorted picture of what's actually going on with global warming. The last thing I just want to show you, hurricanes, these are obviously the biggest ones that we're being told about, and it's also typically the ones that get the most attention. They're also great, again, for TV, and crucially, they're also some of the ones that actually deliver the biggest damage in the world. Again, we have the sense that it's getting worse and worse, but the IPCC actually tells us globally there's low confidence in the attribution of changes in tropical cyclone activity, that's what they call hurricanes, to human influence. So US continental landfalling hurricanes from 1900 till today. Again, we have very bad knowledge about what was out in the middle of the Atlantic or the Pacific Ocean back in the early part of last century because we didn't fly over it, we didn't recognize it. We can see a dramatic drop when the Panama Canal, for instance, opens. So a lot of the ships that used to go through those lanes don't notice these hurricanes anymore. On the other hand, hurricanes that hit the US continental landmass are much, much more likely to have been noticed both in 1900 and in 2020. This is the number of hurricanes that landfall. So this is probably one of the best proxy measures, certainly for hurricanes hitting, being damaging in the Atlantic Ocean. And as you can see, it's a slight downward, certainly insignificant, but downward, certainly not upward trending as I think many people would expect that it was. Then there's also that concomitant idea that, well, we're going to see more damaging major hurricanes. And that's actually probably true in the future, but that's not what we've seen so far. If we look at major hurricanes, also US continental landfalling, they've been slightly declining, not actually increasing. Again, sorry, I should just mention, in the future, we actually expect there will be fewer but stronger hurricanes. Fewer is obviously better, stronger is obviously worse. Stronger is actually worse than fewer is better, which is why we actually expect that there will be more damage, all other things equal. But it's also very important to say all other things won't be equal because we'll be much richer. We'll actually see a lower proportion of damage in percent of GDP. But still, had we had no global warming, it would have been even lower damage from hurricanes. So global warming has a problem built in also from hurricanes. But it's not this, it's just going to get out of hand. It's just going to get worse and worse. It's going to get slightly slower better than it otherwise would have done. So why is it we get it so wrong on global warming? Why is it, I think, most people believe that global warming is an existential threat? If you actually ask people, there's a survey from YouGov in 2019 that asked in 28 countries people if they believe that this will likely lead to the extinction of the human race. And 49% of all people answered across these 28 countries that they think it's likely or very likely that global warming will lead to the extinction of the human race. That's just simply wrong. That's not what the UN climate panel evidence is telling us. And so it's reasonable to ask, why is it we get this wrong? I think to a very large extent, we miss adaptation. So if you ask most people, how do you think deaths from climate over the last century has developed? So the number of deaths from climate-related disasters in 1920 compared to today, I think most people actually think it is getting worse and worse, and they would be phenomenally wrong. If I just show you this, and this is from the International Disaster Database, again, if anything, it's probably underestimated in the past, but we have reasonable belief that all the big ones have been captured. And what we see is in the 1920s, this is again averaged over decades because these are very, very fluctuating numbers. In the 1920s, about 500,000, almost 500,000 people died every year from climate-related deaths. That's floods, droughts, storms, wildfire, and extreme temperatures. And today, that number is down below 20,000, actually the deaths in 2020. But again, they will probably be adjusted upwards. I took these January 2nd, I think, but they were at 8,000. But they'll probably be adjusted up to 12 or 14,000 or something like that. But it still shows us that we have seen a dramatic change from in the early part of last century till now. We've probably seen a decline of about 96 or 98%. And of course, the world population has quadrupled in the same time. So the actual death risk per person from climate-related deaths has decreased by more than 99%. This is very different from our understanding. This is not climate change is now threatening to kill us. No, climate used to kill us a lot. And now, mostly because of increased wealth and ability, technological prowess, we are able to avoid most of those deaths. We miss the ability of us to actually adapt to many of the problems that the world throws at us. Again, and let me show you this, there's only a few studies compared to a lot of the studies that just simply look at what's going to happen, for instance, with sea levels rising, which is absolutely an outcome of global warming. What will happen? How many more people are going to get flooded? That's the typical argument you hear, but you miss the adaptation. So let me just show you this one study from 2014 that very clearly incorporates this. So if you look, this is an average of 3 models. Because how many people are affected by flooding is actually a really, really hard. It's obviously a model estimate because it's very elastic. It's only very few people who die from flooding around the world, so you really can't measure it that way. So about 3.4 million, and again, this is a model estimate, an average of 3 models. About 3.4 million people were flooded in 2000 every year on average. It has a cost of about $11 billion. These are all in the same billions, I believe it's 2010 or 2011 dollars. The cost is about 13 billion in dike costs. So this is what we have to pay for our current adaptation. That's why it's only 3.4 million people getting flooded. And the total cost is about 0.05% of GDP in 2000. Now, if you then look out into the future, and this is what their paper does, and let's take the worst case warming. It's true for all these different scenarios. I'm just showing you one of them. The worst case warming, the highest population, the highest GDP. What will happen if you just look at, all right, sea levels are going to rise somewhere about 70, 80, 90 centimeters by the end of the century. How many more people will get flooded? This is the result that they get. A very dramatic, obviously, experience of, wow, we're all going to get flooded. If you have no adaptation, you're going to see 187 million people flooded every year. Remember, this was the headline in Washington Post and New York Times and many other papers around the world. This number keeps cropping up. It's actually a number back from 2011, and it's a wonderful number. It keeps giving. It gives you this sense of, wow, this is terrible. Of course, this number requires you to assume that everyone lives where they are right now, that they will populate more, so that there'll be more kids around in 2100. And then you look at what are the isocurves of water, and if there's now water where there used to not be water, these guys are flooded. Well, in principle, they have to move. So what you're saying is 187 million people have to move because of global warming. This will have huge costs. Not surprisingly, it'll have $55 trillion in flood costs. The dike cost won't be very much because we haven't upgraded the dikes. The dikes are still at 2000 level. We've done nothing. We've just simply watched the waves lap over more and more, but done nothing. So clearly it has been a very cheap protection cost, but an enormously expensive cost in terms of the average flooding of 187 million people every year of $55 trillion. That's why this will cost 5.3% of GDP. It's also absolutely ridiculous to assume that we will not do anything over the next 80 years. This is a very typical assumption, and I think for many people, it's just simply because academically it's much, much easier to not build in adaptation because it's a whole other layer of complexity. But of course, it makes absolutely no sense to actually inform our politicians with this sort of information without telling them, well, what will actually happen if you do have adaptation. These guys, this particular paper does do that. It also, again, uses what I think 7 different models. This is, again, the average of those models. This is what happens if you have adaptation, because we're much richer by the end of the 21st century. We will basically protect everyone. The outcome is, instead of 187 million people being flooded every year, which obviously would be a disaster, it is 15,000 people. Virtually no one will get flooded in 2100, despite dramatically increased sea levels. The cost of flooding obviously will have gone up because we'll be much richer, there'll be much more stuff to flood, and the dike costs will also especially have gone up. But because we're much, much richer, the cost in GDP will almost be tenfold less. It's 0.008% of GDP. I think this picture encompasses our whole sense of, oh my God, it's the end of the world. Yes, if you forget adaptation, if you forget that we actually adapt to many of these problems, but if you do take that into account, what you actually see is global warming will make things worse. Remember, if there had been no global warming, if there had been no sea level rise, we would have been able to protect people even better. We'd still have built higher dikes because we're richer, but we wouldn't have to build them as high and we wouldn't get as many damages. So we would perhaps, and I'm just making this up because I don't know if anyone's actually done this, but we probably get, say, 0.004% of GDP damages instead. So global warming is a bad thing, but it's a very small part of this issue that we've gone from 0.05% of GDP down to 0.004 or to 0.008. That's the real issue, and that's a very hard one to communicate. So again, if you look at the total cost of climate change, the global cost in GDP, again, they've also been declining over the last 30 years, where we have good data from 1990. So again, it emphasizes that whenever you hear these stories, you typically just, and last year was no different. Early this year, we heard 2020 was much more costly than 2019, which is true, as you can tell there, but it doesn't give you the right sort of sense of proportion, because it doesn't give you actually this picture of how global costs have declined, and we're likely to believe that they will continue to decline, but they could have declined even faster had we had no global warming. So how do we then tackle this? I think fundamentally our climate policy, and I've cut away a lot of my slides because I wanted to get to your questions, fundamentally climate policy so far has shown how not to tackle it. So we've basically been promising climate action for 30 years and achieved very little, I think very unreported. UNEP, so the UN Environmental Program, said late last year that global warming in the 2010s was essentially a decade lost. They said that emissions today, so that's late 2020, are almost exactly at the level of emissions projected for 2020 under the business as usual or no policy scenario. Remember, this was without the estimates of what would have happened. Sorry, this was in 2019 because this is before COVID. Sorry, this is late 2019. So basically what they're saying is that the emissions that we've seen today, or at least in 2019 before COVID, were about where we would have expected it had there been no policy whatsoever. So we've had lots and lots of talk, lots and lots of promises, a little bit of cuts. Many of those cuts are simply cuts that rich world countries have done and basically pushed over the emissions to somewhere else. So we get to feel virtuous, somebody else emits it, but the environment doesn't matter. It doesn't matter much for the environment. If you look at the Paris Agreement, which is obviously the big game in town right now, it will have virtually no impact. So if you look at the UNFCCC, the guys who organized the Paris Agreement, they made an assessment of how much all the promises in the Paris Agreement from 2015 would deliver. It would deliver at the very best outcome. This is the top maximal outcome, is 63.5 gigatons of CO2 by 2030. Just to give you a sense of proportion, if you run this through the standard UN climate model, one of the simple ones like MAGIC, for instance, it reduces temperature by the end of the century by 0.029 degrees centigrade. Basically, if we assume nothing else happens, from 4.1 degrees centigrade by the end of the century to 4.071 degrees. So clearly, very, very little difference. If you assume that we would actually stick to those promises for the rest of the century, which of course is much, much more than what we did with Kyoto or with the Rio promises, the cost would for every year be $1 to $2 trillion a year. Every dollar spent would deliver about 11 cents of climate damages. And again, I refer you to my climate paper, and of course we can talk more about that. But basically, deliver a lot less benefit for humankind in the future than what we're paying for it today. And if we did Paris for the rest of the century, sorry, that was where I thought my slide was going, we would actually achieve about 0.17 degree reduction. So we would not only cut about 7 gigatons in 2030, but we would keep that reduction for the rest of the century instead of just slipping back after 2030. It would be less than 0.2 degree temperature reduction at a cost of cumulative over the century, some 60 to 120 trillion dollars in cost over the rest of the century. And those are obviously undiscounted costs. That's a lot of money to achieve very little good. And that's basically the point that I try to make, that currently we're trying policies, we're probably not achieving them, but we're trying policies that will have huge costs and that will have fairly small climate benefits. Of course, what we've typically taken as the outcome of this is not to say, wow, we need to find smarter policies. It is, we need to make bigger promises, which I would argue is probably not the right way to go. It's also worth pointing out that this will typically be bad for the world's poor. The Paris Agreement is estimated to lead to 4% more poor. It'll also lead us on a trajectory where it's likely that we will see poverty being eradicated slightly more slowly. And of course, for most of the world's poor, the issue, think India, especially most of Africa, the issue is simply getting access to more energy, and much of this energy would be from fossil fuels. Many studies show lots of benefits from access to electricity. I'm just going to show you this one study that we did for Bangladesh. They're planning a series of coal-fired power plants. We did a macroeconomic model looking at what would be the total impact of that. The fantastic outcome would be that it would basically dramatically increase productivity and allow Bangladesh to grow probably to the extent that you would have about 30% higher GDP in 15 years. So let me just show you this. Obviously, these new coal-fired power stations would lead to higher CO2 emissions. If you look at the total net negative of that, that's probably around $0.6 billion in long-term climate damage that would come out from all of these belching coal-fired power plants. But the benefits to Bangladesh would be about $258 billion. All of this is in present-day dollars. So fundamentally, when we're saying, and for instance, Al Gore was saying this to Sheikh Hasina, the Prime Minister of Bangladesh, he said, you've got to stop building those coal-fired power plants. What we're basically saying is that, sure, the Bangladeshis would get $100 of benefits, economic benefits, mostly simply higher employment and higher GDP. But in order for us to save 23 cents of climate damage, we want them to forego $100 of economic benefits. Obviously, that's very, very hard to imagine that you could convince Bangladesh to this, and more generally, that you can convince India or Africa or possibly even China to do that. So let me use the rest of my time here to talk about, so how should we fix global warming? And I'm going to make 5 points. A carbon tax, innovation, adaptation, geoengineering, and finally, prosperity. So the first one, carbon dioxide tax, I think is the most obvious one for most economists. If you have damages, you need to reflect those damages in the extra taxes that you put on here, and this is really just the outcome of so what is the basic outcome of most economists from looking at climate change is to say there are definite costs to, that's why we should worry about it, but there are also definite costs to climate policy. Since we have to pay both, we have that we find the place where we pay the minimum of the cost of the climate policy cost. Nordhaus has done. So this is his estimate from latest from 2017. There are lots of individual studies across temperature rises. How much damage is the world going to see? As you can see, most of them show damage. This is why global warming is a line. And as you go out the x-axis, as you get higher and higher temperatures, you get more and more damage. The size of the circles is Nordhaus' estimate of how credible these different estimates are. So obviously that's a objective measure of how much faith we can put in these estimates. So he basically says, this is my best estimate of the damage cost at 0 degrees. It's about, and as you can see at 4 degrees, it's about 3 to 4% of GDP, which was what that's what we're estimating we'll probably get to if we do very little or nothing about global warming. There is a problem. It is a manageable problem, 3 to 4%. It's not the end of the world. There's lots of things that we haven't taken into account. So he adjusts for emitted damages. Obviously, that's a hard argument to make because you're basically saying, what do we think about all the things we don't know about? Some sort of indications in my article about why that's the case, also in my book. Back to that, but this is his best estimate for the emitted damages. That's the equation that I'm going to be using going forth in showing this is one of the 3, for instance, models that have been used by Obama to estimate the social cost of carbon, and many others. So it's a very, very well respected, but obviously it's only one. They pretty much agree the main impact models, but this is, this is a model still. So just very quickly show you this. If we look at, if we have 4.1 degree, no policy by 2100. I'm just looking at the impacts in 2100, but obviously it'll get. This is actually a discounted cost of all the costs over the into account. But for now, let's just measure it as if it was for 2100. What he finds is the cost will be about 140 trillion US dollars. Anyway, so this is if you go down in temperature, and again, all of these estimates are what happens if you assume that you reach 3.75 degrees by the end of the century in the most effective way. So I'm simply showing you how much would that cost if you achieve that in the most effective way. How much would the climate damages be? Because obviously they're spread over the next centuries. So the cost would be about $105 trillion. Then for the next ones, you get 3 degrees. The costs get even lower, 2.5. His model showed 2.15 degrees is the absolute lowest that you can achieve. Now, this shows the general argument that we hear from everyone, namely that it's better to be at the low end than the high end. This is very obvious. So clearly, why wouldn't we try to go for 2.15 degrees rather than anything else? This makes a lot of sense if you only look at the climate cost. But of course, there's also a climate policy cost. And policy cost for no policy is, not surprisingly, 0. But the cost for 3.75, and again, I'm looking at this for the realistic, good international corporation, the cost is about $20 trillion for 3.75. It gets even higher. It's almost $100 trillion for 3 degrees. It's obviously much higher, and for 2.15 is fantastically high at $350 trillion. The point is, given that we have to pay both, we really all these climate costs, but then we also have to add on, just added on the no policy cost, but then we add on the policy cost on the 3.75, and then we add on so on. What we find here is the optimal outcome. This seems very, very wrong to most climate campaigners because they're only looking at the black bar. They're simply saying, if we can make the black bar smaller, obviously it'll be much. We end up with fantastically costly climate. Optimal outcome in Nordhaus model is somewhere between 3.5 and 3.75 degrees centigrade. That means a carbon tax of about $20 around now, rising over the century so that you will have reduced emissions about 3/4 by the end of the century. So it's not a small outcome, have a smaller impact on the total temperature.
So that was the first part, the carbon tax. Then we also should focus, and I would argue, mainly on innovation. So this is innovation is really how we fix most big challenges in the past. When we were running out of whales back in the 1860s, we didn't tell everyone. Remember, we were fishing whales almost to extinction because they provided this wonderful oil that lit up homes in Western Europe and Eastern US really, really well without soot. It was very hard to tell people, I'm sorry, could you stop doing that? Could you dim your light, go back to using camphor oil and have more sooty light? That's a very, very hard argument to make. What did work was we found oil and basically found petroleum in Pennsylvania in 1862 and suddenly had a cheaper product that was better. That always helps because that makes people say, all right, I'm not going to use whales anymore. And basically, that's one of the reasons why we save whales. It's obviously not the only one, and we also went back in the 20th century to start fishing whales again. But the whole point here is, if we focus on innovation, instead of telling people to do with less, we can actually get people on board with doing with more. So asking people to do with less is rarely an attractive policy. So it's really a simple insight of saying, if we could innovate the price of green energy down below fossil fuels, we would have won. We would have solved global warming because everyone would switch, not because they're greener, because they want to do good, but simply because it's cheaper than fossil fuels. So my point here is to say we should simply be investing a lot more in green energy R&D. If you look at, for instance, how much EU wind and solar cuts, it cuts about 100 megatons of CO2 per year, but it costs EU about $40 billion, whereas US shale gas cuts almost 3 times as much, and it makes the US about $300 billion. Obviously, it's a lot easier to argue, let's make a lot of money and cut more CO2 than to cut less but pay more. The simple point here again is to say, focus on spending much more on innovation. We've actually done that, and this, I'm proud to say we had a tiny bit of impact on this. And the sidelines of the Paris Agreement, there was the mission innovation, where 20 governments, including the US and Germany and many others, and Bill Gates and many other billionaires, promised to double green energy R&D funding by 2020, and we didn't actually deliver on that. If you look at the OECD and the US, we have not seen significant movement since 2015. This is where our promises are, and we're not going to make those at all. We should dramatically increase it. We actually estimate you should probably 6-fold increase it to about $100 billion a year. Just to give you a sense of proportion, these are some of the benefit cost estimates that we've done. For the EU 2020 climate policy, we estimate for every dollar spent, you will avoid about 3 cents of climate damage into the future. The Paris Agreement, as I mentioned, will avoid about 11 cents. A smart global carbon tax, as I just argued for before, will be fairly expensive, but it will be beneficial. It'll avoid $2 of climate damage for every $1 in economic cost to the hit of the economic growth, whereas innovation will probably deliver about $11 back on the dollar. That's why innovation is by far the most likely solution to actually fix global warming in the long run. Let me just, I know that I just got 3-4 minutes left. Let me just go, is the audio better?
Yeah, the audio is great.
Wow, okay, so that's just what we should have done apparently. Sorry about that.
Okay.
Well, that goes to show. So anyway, adaptation is obviously one of the things that we should be aware of. I started out talking about how this is incredibly important for us to understand that much of what we're seeing from climate change that could be potential damages will be avoided because we will do adaptation. Much of this will happen without us needing to plan at all. Most adaptation happens because it's privately smart. If temperature rises, you will have farmers plant later or plant later, or maybe plant something entirely different. So you have a lot of people making choices, but obviously some adaptation you can't have individually, like sea level rise. You need to have public adaptation with dikes and water protection measures. And often these paybacks are at 100 or more per dollar spent. Often these are very, very good investment. That's why they will happen. They should happen. We don't, for instance, see them as much in the US as elsewhere. And I suspect that there's part of it is simply because of bad public governance. It's also a question just simply lacking the funds. Whereas Holland, for instance, is a great example of how to do this very well. Many other policies are also smart, but a lot less impressive. We found on average, agricultural adaptation. Many others have a payback of 2, 3, thereabouts. 2 more things. We should look at geoengineering. We should not actually do it, but we should invest in research and development into geoengineering. Again, for those of you who are not familiar with geoengineering, we know that you can essentially put sunshades on the planet. Mount Pinatubo, the volcano in the Philippines in 1991 erupted and basically cooled the planet for about 18 months, about ½ degree centigrade, by spewing into the upper stratosphere lots of small particulates that basically reflects the sunlight, so less energy gets into the planet, and so you get a slight cooling of the planet. We could do something along those lines. We could also imagine doing many other things. We've been looking at cloud whitening. We simply argue we should be looking at it because it is very cheap. it is very likely to happen somewhere. It's very likely over the next 50 years because it's so cheap that some, say Indian billionaires just simply going to decide to donate it to humanity, even if we don't want it. Or maybe even a very enthusiastic NGO might be able to scale up something like this. And also, it's the only policy that can work really, really fast. So if we see something like catastrophic melting of the West Antarctic ice sheet, it's the only thing that can have an impact in just a few years or even a few days, whereas obviously any realistic climate policy will take many decades, possibly even half centuries, to have a significant impact. We should not start this because it's obviously very controversial and also because we don't know enough about whether it works, but we should be looking into whether it works. It's one of the ways that we could also help inform that Indian billionaire, that hypothetical Indian billionaire who would do something about it. If there is something really bad lurking in doing this, it would be nice to know that it is bad. So that's why we should be investigating it. And also, obviously, we should be investigating it because it's potentially an incredibly cheap way of achieving much of the goals. So we estimate for about $9 billion for one technology, which is marine cloud whitening, you could get a benefit of about $60 trillion, which is obviously an unheard of benefit cost ratio. But again, we don't know enough. We should certainly start spending money on knowing about this, but we shouldn't actually implement it just yet. The last bit I just want to emphasize is prosperity. It's probably the one that we talk the least about in climate policy, but we should, because clearly, if you are well off, you're much more likely to be able to handle most problems from climate. This is the Schelling conjecture, and in many ways we've seen that that is true. I'm just going to show you a very few outcomes. So this is the UN Climate Panel's shared socioeconomic pathways. You may know them, the SSPs. If you look across, this is just the GDP per capita over this century. So middle of the road is probably the most likely outcome. The two best outcomes is sustainable development and fossil fuel development in terms of GDP per capita. What you see is we're likely to see the average person at the end of the century be about 450% as rich as he or she is today. And we could see people being more than 10 times as rich as what they are today. So clearly, there's an enormous amount of potential going forward in people becoming much, much richer. But obviously, climate change will also have a negative impact. So if you look, for instance, on the sustainable development, yeah, you will get to more than $100,000 per person per year in present day dollars. And in fossil fuel development, we'll get to more than 180,000. But clearly, we will also have climate change damage. Using the Nordhaus model that I showed you earlier, sorry, this is in Fahrenheit. I should have changed it into centigrade. But it's yeah, I can't do this on the run, about 3 degrees. Then it'll cost 2.5%. So it'll actually be equivalent to having an income increase of a little less, so 2.5% less. So still over 100,000. And likewise, the fossil fuel development will obviously see much more warming, so it'll also have a much higher damage. And that's why you'll still see a significant reduction down to about 170,000, but still dramatic outcomes. And of course, the important point here is to recognize that the outcome in choosing the path, so do we choose sustainable development or do we choose fossil fuel development, matters a lot more to what the world is going to be like in 2100 than just the impact on climate. If you look at that in Africa, that's also true. You actually get much better outcomes in Africa, even though you will get much, much higher damage, especially in Africa from global warming. As you can see, we're also estimating much higher global damage cost. If you just look at Bangladesh, if you look at Holland today, Bangladesh in the middle of the road will be about as rich as Holland is today by the end of the century. And the real issue here is then, well, what should be our choice? If we want to help Bangladesh, one way to help Bangladesh is to make sure we cut carbon emissions so it'll have fewer sea level rise to contend with by the end of the century, and a few other impacts from climate change. But obviously another important way is to make sure that they become sufficiently rich, that they can tackle many of the problems. And obviously if they're as rich as Holland, which they likely will be by the end of the century per capita, it's likely that they can also tackle problems like sea level rise and many others. And clearly, if they get to a sustainable world, or even if they get to a fossil fuel world, we can actually bring forward by, say, 3 decades or more when they actually become as rich as Holland is today. So that's the, sorry, I'm not sure this. Oh, sorry, I'm going backwards. That's why I didn't quite understand. So it's important just to also emphasize that by the end of the century, the difference in the two pathways, the two best pathways, you might say, between sustainable development and fossil fuel development is about $500 trillion in global impact per year for the world. Clearly, that can be translated into a lot of other opportunities to tackle malaria and many other problems. Most of those won't be there anymore because we'll be too rich, so there'll be other problems that we'll be mostly facing. So if I could just summarize very quickly, and then I'll shut up, and I won't get to my point right now about all the other problems in the world, but basically what works and what doesn't. Global warming will cost about 3% of GDP across the next 500 years. That's a problem, not the end of the world. If we do a smart CO2 tax, we can reduce this by 0.4%. That's great. We should, 0.4 percentage points, so down to 2.6. We should definitely do that. Has a benefit cost ratio of 2. That's a great idea. Please, let's do that. But also, let's be very cognizant of not doing too much. We should definitely focus on innovation, because that is the only way I really see that we're going to fix climate change in a realistic sense. We should look at adaptation, but we should also be wary that it only has so much good it can do. We should do R&D for geoengineering, and we should be focusing on prosperity. With that said, I'm going to shut up, and I'll just turn on my screen, and I hope you can still hear me. So thank you.
Yeah, thank you so much. I will applaud in emoji. Yeah, that was a great talk, and we are now going on to the question and answer session of the talk. I think we have about 40 minutes for that. And I think I'll start off with a question. So first of all, I really like the talk. I especially like your point about adaptation. I mean, I study in the UK, but I'm Dutch. And I don't think the Netherlands would be here without adaptation. We of course, build dikes, and it makes sense that people would do such things. And for my question, to start off the question and answer session, is I also really like the idea of geoengineering, but isn't there a kind of market failure there? Because geoengineering will presumably affect the whole planet. And that means that countries that, for example, don't invest in geoengineering will still benefit from that project, from investing in geoengineering, or from other countries investing in geoengineering, resulting in no countries investing in geoengineering, because we can all just wait for someone to do it, and then it will not end up happening. Is that a problem? Or
no, it's not really a problem, because it's so cheap that anyone could do it. So that the funding is not going to be the problem. Imagine another thing. If we could suck out CO2 from the atmosphere, right now it costs perhaps $100, $200, which makes it an impossible to imagine that we could suck out all of it, that we would be able to afford that. But if it only costs, say, $1, it would, I can easily imagine the EU just saying, all right, guys, we're just going to pay for the whole thing and get it over with. They would do it with more fanfare, but we would do that. If things cost very little, you'll get it done. The problem with geoengineering is not paying for it. The problem is who gets to decide what the where the thermostat goes. Imagine having that conversation between Ghana and Moscow. It's very clear that Russia would like the thermostat a very different place. The reason why we have said we want to go back to prehistoric times is twofold. Partly because that's where we have most of our infrastructure is adapted to, so that makes sense. It's also a sort of focal point for game theoretical considerations. But honestly, there's no reason why any particular nation should want this And I think if we actually had geoengineering, there'd be a lot of debate, and it's unclear whether we could actually get that fixed, find what's the right temperature for the planet. And I'm not sure how to deal with that. I think that's one of the reasons why we should only research it and not start implementing it now.
Great, I'm glad I asked. Okay, there's other people with questions, and I think it's fun if people can ask them themselves. Also, could you stop the screen? Well, maybe people will have questions about the slides, so I guess we can keep them up. Okay, so yeah, if people want to ask questions, then I propose that they unmute themselves and ask them. For example, Eric Marcus has a question. So if maybe Eric Marcus wants to unmute himself and ask away, and otherwise I'll ask.
Yes, yeah. So thank you, Dr. Lomborg, for the great talk. So one thing that I'm a bit worried about. So when you were talking about innovation, I imagined it was kind of money from the government. So how do you make sure that this money ends up at the right place? So for example, there exists a lot of policies that support the buying of Tesla cars and stuff like this. And I don't suppose that's the innovation that you meant.
No. Yeah, no, that's a great question. And very broadly, yes, politicians are very, very bad at a lot of things. I mean, they also get a lot of things right. That's why we're pretty well off. But especially climate sort of lends itself to a lot of virtue signaling policies. So, you know, for instance, Biden wants to invest in 1 million US electric cars. And let's just get real, you know, electric cars are going to be wonderful in 10, 20 years from now. But they're a terrible way to cut carbon emissions right now. They're an incredibly expensive way to cut a little bit of CO2, but they look virtuous and they're great to sort of make promises with. Also remember, almost all of them go to rich people. So it's a very, very ethically skewed or regressive way really to distribute money. So the innovation should be investment in R&D. So this is not about, and a lot of public policy, I think it would be more likely that public policy would be, we're going to spend another $1 billion or $10 billion on innovation, and we're going to give it to companies. Well, if you give it to companies, they're going to develop the stuff that they were going to do anyway in 3 months or in 2 years, which is not very helpful. This is not about getting the next iteration of a wind turbine, although that's wonderful to get, but we'll get that certainly on market conditions right now. It's about making sure that we actually get people in the long run get much, much better innovations for all the things that we don't have good innovations for right now. So, battery storage, are there other ways to keep storage? Fourth generation nuclear, certainly we should also be looking at fusion. Craig Venter has this wonderful idea, the guy who cracked the human genome. He has this idea of using algae, genetically modified algae on the ocean surface to basically soak up CO2 and sunlight and make oil out of it. So we could keep the entire infrastructure that we have right now, but it would be CO2 free or essentially CO2 free oil. There are lots and lots of ideas out there. We want to help all of them. So the way I propose that you should do this, and I'm not saying I'm a perfect advocate for this. This is just sort of a first sketch. If you were going to spend $100 billion a year, right now we spend about 15 billion. So that's a huge scale up. Remember, Biden by himself is promising to spend 85 billion. So he's basically proposing all of what we're saying. And I think it's very dangerous that that will be wasted because it's just hard to imagine that you can scale that up in the US. But let's just assume that you can actually do that. You would do blue ribbon panels across a wide range of areas. So, within, say, storage energy, what are the innovations that we need? Let's say, what are the 100 innovations that would be really great to get over the next 10 years? And then we spend, say $1 billion through the National Research Foundation funding sources or equivalent in all other countries, through those pathways to try and solve some of these problems. So you would be a researcher in storage. You would see this blue ribbon panel. There'd be 100 ideas that you could follow. You'll say, I want to be the guy who solves number 87. You'd ask for money and you presumably get it if you're really smart. Chances are you're going to fail. A lot of other people are going to fail, and we'll get 3 of those 100 things actually innovative. But that's okay, because we really only need a few of these to come through, and they're the ones who will power the 21st century. So this is, this is just simply about doing this in a lot of different places. And likewise, the UK would do it in one way, the US would do it another other way. In Denmark, we probably want to do it more with wind turbines, because we feel that that's where we're good. And there'd be a lot of different ways, and we probably not coordinate it perfectly and all that stuff. But the crucial bit is the money has to go to researchers and not basically just be income for businesses or just show off for politicians. And I think that's where you need to say research, research, research all the time.
Great. We have some people who ask questions but who don't have a mic. And one of them is David van Eijnatten. And so I'll read his question for him. He asks, I get why you would use the UN as your main source of information when talking to people who are worried about climate change. Why would someone who's not worried about climate change listen to the UN panel, considering how untrustworthy they turned out to be during the pandemic?
Yeah, so I'm not going to get into that whole pandemic thing. I think there's, it's hard to know. I think there's really only one thing to be said on the pandemic bit, which is to say, I don't know if you noticed that World Health Organization, like many other organizations, jumped on the global warming is one of the biggest problems. So they were telling us global warming is this big, big problem, like most other UN organizations. And remember, they're right in saying that it is a problem, but they're probably wrong in saying that this is the biggest problem. Certainly for healthcare, I think that's almost laughable to say that that's the biggest problem. And I think in some way you could argue the reason why the World Health Organization was somewhat blindsided by the pandemic was because they were so focused on climate change and many, many other things. It wasn't just an issue of climate change. So I think there's something to be said of, stick to what you're actually good at, and let's not all say that this is only about climate change. I don't think the UN on climate is bad. I think they're actually really, really good. When you read them and you read the research, I think they get a lot of things right. I think there's some things that are problematic, like the way they do the press releases and the way they do the summaries before they actually release the actual scientific reports. And this field is permeated with politics, absolutely. But I actually find them to be pretty reasonable. And again, I think if we're going to have this conversation, because it's such a fraught discussion, we need to somehow agree we're mostly going to take our starting point in the UN. Otherwise, this conversation just fractures beyond belief. So I get where he's coming from. I don't think the UN necessarily does everything the best. I certainly have my gripes with UN Secretary General Guterres, but mostly I think the UN climate panel has actually done a pretty good job. Yes, there's been failures here and there, but I think it's very, very wrong to sort of compare it to the pandemic conversation of these serious panels trying to do something for 5 years and trying to summarize the evidence.
Okay, thanks very much for answering. I see we have someone in the chat, Charles Dart, who has a question. Go ahead, Charles.
Yes. Can you hear me?
Yes.
Yeah. Okay, perfect. Yeah, thanks for the talk. I would like to question, how do you manage to get to the number 11 for the benefit to cost ratio of innovation? Because I suppose that's like the big argument is innovation should be good. Then you have sort of fivefold. We have a fivefold incentive to go innovation versus CO2 tax. But how can you back up this number?
Yeah, it's a good question, because fundamentally it's about what will be the benefit of money we haven't spent yet on stuff we don't know yet. Clearly, you can't say that, because that's, I think it's Popper who made that argument. That's why we fundamentally can't know the future, right? Because if we could understand the future findings, we'd already know them. So there's a fundamental problem in making this argument. Nonetheless, we do need to make some sort of argument as to how much is this worth. So this was estimated by a couple of academics from Canada, in our project where we tried to look at how can you best spend a dollar on climate to do the most good. We looked across all these areas. This is also where the research comes from for the geoengineering. And what they tried to do was to look at what are the benefits of other investments. For instance, in agriculture, we have lots of knowledge about how we spend money on research and how that translates into benefits in the long run. We also have some of that, but not quite as good in healthcare. So we do have some estimates, but in some fundamental way, this relies on the fact that we believe that energy will be somewhat like agriculture or health. It may be none of the sort. And in that case, yes, we're up creek and we have no idea. I would simply say it's the best guess that we have. It's a pretty good guess. I feel reasonably comfortable with it, but obviously you should not believe it like it's 11.0. It's probably more like it's a low, double-digit kind of thing, but who knows? But there's very good evidence that it's above 1 and that it's strongly above 1. But yes, and I think we would also, in any realistic world, you'd want to say, all right, let's start spending more money. Let's see how well we spend it. And then let's go back and revisit, are we actually doing this well?
Nice. Thanks for the answer. Yeah.
Great. We had someone send in a question, which I'll read out now. It goes, complex systems like climate change are poorly understood and difficult to model and predict with accuracy, especially in the long term. This means that when trying to decide on actions that mitigate the long-term risks of climate change, cost-benefit analysis is of limited use, as it is difficult for us to predict the long-term risks and costs. Some people argue that in these circumstances, we should employ the precautionary principle. This principle states that if there is a risk of major irreversible damage, then we are justified in taking serious action to avert this risk, even at reasonably large costs in the short term. What do you think about the precautionary principle?
So, yes, it's a good question to say, how do we deal with the inherent unknowability in much of what we're talking about? We're talking about models, both in climate models, but also economic models. And remember, this also is predictions about how many kids are people going to have in 50 years and what's going to be their education and their nutritional status and all these other things. Obviously, this is assuming a lot of stuff. My sort of simple answer would be to say, well, our best guesses are probably better than no guesses. But that's not really what the question is asking. He or she is saying, well, if we are really worried, maybe we should just take the precautionary principle and say, let's spend extra money here because, hey, it's better to be safe than sorry. That sounds really good until you realize what that really means. It simply means that we're not going to think about other impacts because there's never such a thing as a costless precautionary principle. Let me give you one example. If you look at in Europe, about 44,000 people die on the roads every year. And we have the perfect technology to reduce that number to 0. That's just simply setting the speed limit at 5 kilometers an hour, and then nobody would die. We don't do that because it has other costs. It has other knock-on costs that most people are unwilling to take. And so unless we have that active conversation about saying, all right, so you want to spend extra money, we don't quite know whether it's going to do good, but you think there might be a chance that it would do good in 2100. Shouldn't we have a talk about, one, where could we else spend that money? Remember, right now, about 1.6 million people die each year from entirely curable tuberculosis. A little billion people are starving each year. About 2 billion don't have access to clean drinking water, sanitation, and electricity. They're not the same people, or they're somewhat the same people, but not totally overlapping. There are lots and lots of other problems. Why we're not thinking about those people right now? And if your goal is in the future, and that's another philosophical conversation, do you want to help people now, or do you want to help people in the future? Typically, economists would say, and as I showed you with the SSPs, people in the future are going to be much, much richer. So really, when you're talking about helping people in the future, you're talking about helping rich people in the future or poor people now. Why is it we're so concerned about rich Bangladeshis in 2100 rather than poor Bangladeshis right now? But if you are really worried about rich people in the future, Is helping them by cutting carbon emissions really the best way you can help them? Clearly, you could also do some other things like, for instance, invest in innovation. We know that that would help them in innumerable ways. Or we could simply invest in making sure that they get higher prosperity, which also will leave them much more robust to the future. So I think the precautionary principle often just becomes a soundbite that you use to say, I'm sorry, I'm too tired to actually argue for my favorite thing, so I'm just going to say precautionary principle and hope everybody else shuts up. Well, the actual argument has to be, why is this a better spending than spending on people who have tuberculosis now, who are poor today, and probably some of the poorest people that will ever exist for the rest of humanity's history? Or why is this the best way to help rich people in 2100 when there are so many other ways that you could probably help them better? I would argue that I've made the argument for both of those that are better than these precautionary principle arguments for climate policy. But it's a reasonable conversation to have, but it's an honest conversation we have to have on the facts and not just on a precautionary principle.
Hi, thanks. Thanks for that. If I could just weigh in here, I completely get where you're coming from, and I do think that people sometimes just want to say precautionary principle, wave their hands, and then not say anything. I think just to be completely fair to the people who do support the precautionary principle, I think that what their main concern is you've got this large, extremely complex system which is very poorly understood. What we do know about these complex systems is that they kind of have these critical points where, when you get beyond a certain point, they're going to have these kind of major reversible damages, and beyond that, we don't actually know how serious that could be. I mean, we could be talking about, we could be talking about wide-scale societal collapse, and then especially when we're talking about it's not just the climate change, it's not just the climate which is extremely complex and poorly understood. It's also about how human beings are going to react to that. We don't know what exactly those. I mean, it's kind of easy to imagine a situation where India, a country which is 1 billion people, highly water stressed, relies heavily on very water intensive irrigation systems. If climate change turns out to affect it much worse than expected, it suddenly starts relying much more heavily on water desalination, which is very energy intensive, and it pollutes far. It becomes far worse polluting than China, and then so you could imagine these kind of feedback loops. Plus of course the natural feedback loops, which we don't really understand. Things like no one's really monitoring the permafrost. We don't really know at what point that's going to reach a tipping point, and so on. So there's kind of all these various tipping points which we don't really understand, and we can't reasonably cost into our analysis. And then we say, well, if we think that actually things like yes, so if we think that if things were to turn out dramatically worse than we expect, that would be actually really, really bad. I mean, far worse than just a few people die. I mean, it's not like the road traffic thing which you talked about. It's very, very different to that. So I'm not saying we should just apply the precautionary principle wherever, but when we're dealing with these kind of really large, complex systems, and you're talking about risks that potentially have these really large downsides, why not just avoid the risk?
Yes.
We're picturing someone who's.
So
yes,
I
just jump in there.
That's a very, very interesting point. So just very briefly, you're absolutely right. And that conversation is obviously one that we should have. But then I think also we should recognize that we have tons of other risk points lying around all over society. So, North Korea is an obvious thing. Why aren't we worried, panicky? I mean, it seems implausible to me that North Korea is not, certainly a non-zero, but, actually a reasonably large percentage risk that North Korea will fire at least one nuclear missile at the rest of the world over the rest of the century. Why aren't we panicked about that? Why aren't we panicked about lots and lots of other things? And if you look at more sort of general things, why aren't we disturbed about the fact that the usage of, I don't know, Facebook and the internet and all that stuff, it's totally changed how we interact as human beings over the last 20 years. Shouldn't we, sort of scale back on that? Because what are the risks point that will have sort of a fallout? You can make an argument that Trump was one of those sort of bad outcomes. depending a little bit about how you feel about him. But I certainly don't feel particularly well disposed towards him. The sense is that you could argue a lot of things are out of our hands and could have tipping points just around the corner. So maybe for precautionary sake, we should also switch off all our smartphones and maybe curtail the access to social media or all kinds of other things. This very, very easily explodes out of hand. I think this is a worthwhile conversation to have. I would refer you to one conversation that Nordhaus actually had on this particular point, because we have an empirical point. Back in the 1990s, NASA was researching what are the objects that could potentially hit Earth and basically extinguish humanity. And they proposed to start a project that would survey essentially scan the heavens and find 90% of these objects. And it would cost, I forget what the actual number was, a low billion-dollar number. Then they also said, we can also find 99% of these for you, but it'll cost about $18 billion more. And the US Congress said, no. We actually have a data point where people said, yeah, you know what? We know that there's 9% out there that could extinguish humanity, but it's a risk we're willing to run for $18 billion. We've actually put a price on how much we care about humanity. And I would argue we do that all the time, because there are lots and lots of things, and North Korea being the easiest one. I don't have a good sense of what we should do about North Korea. Well, let the next administration deal with that. Let's, kick down the can and they'll figure it out. We do this with all kinds of problems. So while it's intellectually very right to say climate change has all these breakpoints, I think almost anything we do have all these tipping points a little bit out, and we often just ignore them. And I think if we're going to have an honest discussion, if we're going to talk about it in climate, we should be talking about it in all other areas. And we don't. And largely because we've succeeded, and I'm not saying this is right, we've simply succeeded as a civilization by mostly saying we'll fix our problems and we'll let the future deal with their problems.
I'd just say I don't have a smartphone. I agree with you that social media is dangerous, and I think that we should be taking these more risky kind of existential risks far more seriously. That's all I'd say there. I can see that other people might differ.
Yes, so we have another question in the chat, which is, what are your thoughts about, or do you have any thoughts about the psychology of human nature that has resulted in the prevailing orthodoxy that climate change is a grave existential threat to humanity?
I mean, obviously I've thought about it. I don't have any professional opinion on it, but I think there's certainly something in our psyche that likes believing the end is around the corner. One of the reasons is it makes us live in interesting times. It makes us feel like we're part of this generation that really could make the difference in the world. Whereas the truth is we're more like one of the many generations that are going to help make the world a little bit better over the long term, and nobody's going to remember us in 100 years kind of thing, which is not nearly as sexy. So if you look back, we've always thought that the world was running out or dying in some way or another. It certainly seems like it's a very, very viable meme. And I would argue that it clearly makes for great policy. I think that's really the biggest problem. It's wonderful for politicians to be able to say, you're going to die unless you vote for me. I can save you. I mean, how can you beat that? So clearly, politicians just love this. Mencken said, politics is a whole series of hobgoblins, most of them made up, that are made to scare people in order to make them vote for you. And I think that's a little cynical and probably a little too cynical, but I think it has a significant amount of truth. That's why we've had lots of wars before, and climate change. And if you think back, acid rain, ozone layer, running out of resources, but also the war against the Soviet Union, lots of other wars beforehand. They all have parts of truth to them, but they also have a lot of exaggeration. Remember John F. Kennedy won on exaggerating the number. This is making a very easy argument, but won by saying that the Soviet Union was way ahead on nuclear launch vehicles in 1960. Pretty much everyone in the know knew that that was false, but but they couldn't talk about it. And that was one of the reasons why he said, Nixon's going to be weak on this. I'm going to be strong on it. Vote for me. And this just works all the time, exaggerating the threat.
Yes, that makes sense. Great. And then I actually have another question. I see. My question might be a bit long. I see Liberty has a question. Go ahead, Liberty.
I have a quick question, which is just how would you address the ecological effects of climate change? So you've talked about the effects on humans and argued that we can use a cost-benefit analysis in that case. But I think people who are worried about climate change are also worried about vulnerable species going extinct and that kind of thing.
Yes. And that's a real problem for cost-benefit analysis. I would say two things. One is, by all estimates, if you look at what really is damaging for the natural world, climate change comes towards the end of that. So if you want to help, it's about avoiding deforestation, it's about avoiding encroachment, it's about overfishing or overuse. It's all those things that are much, much easier to do something about and where you can much more clearly have an impact right now. Now, if we actually fixed all of those, then obviously global warming will suddenly become a bigger part of the problem simply because the problem becomes smaller. But let's worry about that when we get there. So I would say if you really worry about those, there are many other policies that are much more likely, much more plausible, much cheaper, and much more effectful.
Then I think I have another question, which is, you kind of mentioned that there are these other projects that we can also spend our time on. I'm really curious what the kind of cost-benefit analysis of that is. Where does climate change rank among the other things that we could be doing with our money and time?
Yeah, so I run a think tank called the Copenhagen Consensus, where we work with some 300 of the world's top economists. We work with 7 Nobel laureates in economics. And we've looked at a lot of different things. We've just finished a project in Ghana where we looked at what are the smartest things that Ghana can spend money on in Ghana for Ghanaians. And we've done that in Bangladesh and in India and Haiti. And right now we're starting working with Malawi, doing the same thing. But we've also done this on a regional place and also a global one. We did that last for the Sustainable Development Goals, so the UN goals from 2016 to 30. And what we found was, if you know about the Sustainable Development Goals, they're basically, it's 169 targets that are incredibly wordy and basically promises everything to everyone everywhere. So if you're in an NGO, you'll typically say, my thing is in the SDGs, and that's true, but so is everyone else's. It really is nothing. There's no priorities, and obviously if you say everything is a priority, nothing is a priority. So what we try to do is to say, well, look across all these areas. They're all nice. Obviously, we should all, in principle, want to have them. Given that we don't have infinite money, where can we do the most good? Remember, the SDGs both promise we should get rid of poverty, which I would say is probably a very good thing. And we should also make sure that we get parks, urban parks for handicapped people. Yes, that's also a good thing. But if I have to choose between the two, I'd probably focus first on nutrition and poverty and that kind of thing. So we try to look at, it's not just a question of how good is it, but also how much will it cost. And so we looked at, with cost benefit eyes, where can you have the biggest bang impact? And I'm not going to talk a lot about it. You can put this up. I can just send you that that slide afterwards. We did a big book. Oh, I have it right here. We did a big book with Cambridge University Press. Fun to read, but it's very, very long. But we also did a one-pager for politicians. So it basically just has, so these are all the different targets that the UN were talking about out here. And for each one of them, there's a cost-benefit analysis. And then for each one, we say it's going to cost this much, it's going to do this much good socially. So it's not just the economics, but also save people's lives, make people's lives better. It's also going to do good for the environment when that's relevant. We've tried to do all of these things and incorporate it in here. If we've done it right, basically what you can just do is look at each of these targets, and there you can see how much bang are you going to get for your buck. So if you spend £1, you're going to get this many pounds of good. If you spend €1, you're going to get many euros of good, and so on. So this basically means do the long lines, don't do the short lines. Now, there are lots of reasonably short lines. Remember, we didn't take in all the stupid ones. There's mostly, these are all good. These are just so good, and these are phenomenally good. So just to give you a free trade, incredibly good, lists hundreds of millions of people out of poverty. Family planning, immensely good, both because it saves women's lives, it saves kids' lives, and it improves economic growth. Get immunization for small kids, tuberculosis, malaria, so on. There are lots of really, really smart things. Now, climate comes, if I can see down here. This does not mean it's a bad idea. That's the 11 that we talked about before. But obviously, compared to like 60 back on immunization, it's not the best. But we're an advanced civilization. We can do smart things from a lot of different things. But what we should just be very careful of is not do all the things that do very little good. So, take a look at this. And if you want, all the papers up online as well. And you can read how they got to them. And these are all some of the top economists in the world. So that's really what we try to do, to say, look, if we overspend on climate, it simply means that we can't afford to spend on all these other things. So if we spend reasonably on climate, it also means that we actually have money left over to fix all the other problems that also matter.
Yes, great. Yeah, I really like the
5 minutes. So just so I have another call.
Yes. Yeah. No, I really like the graph. I think in the past you described it as a menu for politicians, so they can see what is the most important thing to focus on. We'll put it up on our website or on Facebook and probably in the video. And yeah, I don't think there's any further questions. So. Yeah, I would like everyone to join me in thanking Bjorn Lomborg for his excellent talk and for his time. And yeah, thank you very much for joining us.
Thank you, Sam, and thank you, everyone. It was a pleasure.